Thank you, guys. Good morning. Actually, glad to be here and hope you are not so sleepy because it's early time, and I hope you had time to have some coffee. So yeah, my name is Dani, and today I'm going to tell you about some insights of how we developing our LLM assistant to overcome loneliness. And actually, I will more focus on some practical aspects, especially how we measure the quality of our Copilot. And also tell you about why and how we decided to do it. So let's start it. And before, let me quickly introduce you with the Social Discovery Group and tell you what the company is actually doing. So Social Discovery Group is a global technology company that focuses on building apps. And actually, these apps are in the intersection of communication, social, and entertainment. The company's portfolio has 60+ online communication platforms with focus on AI, with focus on video streaming and gamification. These platforms are rolled out for 500 million users, so it's also our portfolio, and these users are all around the world. So this apps used by 150 countries. And let's start with why we decided to build an LLM assistant. And actually, it was a data-driven decision. So we, during analyzing dialogues of our users, we noticed that sometimes they face some communication problems. And those problems are listed at this slide. So users often feel hesitant in the beginning of the conversation. They sometimes struggle with responding to and asking questions, and also maintaining a dialogue could be challenging for them. So we would like to help our users to overcome these barriers. Yeah, and this is how the Copilot, that's the short name of our LLM assistant, was born. So Copilot is an AI tool that simplifies communication, experience of users via chat suggestions. So at the slide, you could see how it looks like. This is our interface. And actually, it works in the following way. So we ask a large language models to continue the dialogue with 2 suggestions. Then, after suggestions are generated, we show it to the user, and then user could use it as a draft for his message. And actually, he could send it without any modification or modify it in some way. So it's up to user. The question is, should you train your own LLM? And actually, speaking about training your own LLM, I mainly mean fine-tuning, but not pre-training. So this is because of 2 reasons. The first reason is that pre-training is too expensive and actually a complex task, while fine-tuning is actually enough in many real-world tasks. I guess 99% of real-world business tasks could be solved via prompting or fine-tuning, so it's enough. And a good way to understand whether you should train your own network is via prototyping. So start with implementing a baseline MVP, for example, using API of any open source good model. Then measure the impact on your business metrics, and if you see any impact, you could consider developing your own LLM. Actually, possible benefits that fine-tuning could bring you includes even higher impact on business metrics. Also, it lower cost inference comparing to using external APIs, and it's more flexible because you fine-tune your model in a desirable way. So it's the same pipeline we used, and we started using frontier models APIs and actually measured the effect on our business metrics. And what we saw that actually users started to use this Copilot. They became somehow interested in it, and also via metrics, we understand that user engagement has increased. After that, we started thinking how to make it even better, and understanding the specifics of communicating on our platforms, and also reading the dialogues of user communications, that suggestions sometimes are not so suitable. We understood that fine-tuning is our way to improve the model's quality. And after this, we find ourselves in a cycle of iterative model improvement. So this cycle consists of 2 stages. The first is a training process, and the second is quality. So the top-level training process consists of experiments with different configurations. These different configurations includes different neural network architectures. It includes different ways of cleaning and collecting data sets, and also it includes different hyperparameters in training stages. And I guess one or even several lectures is a good have to be devoted to this topic on how to train it in a better way. But for now, I would like to focus on the second step, which is the quality measurement. Speaking about why we need model measurement, the short answer is we can't manage what we can't measure. And the longer answer is that as we train our models, as I told, via different experience with architectures and configurations, quality measurements allow us to understand whether the step that we have chosen is the right one. So if you use a metaphor from reinforcement learning, actually quality measurement acts like a reward. So it helps guide us in a way towards the best AI copilot. And now I want to break down this quality measurements pipeline in different stages, and actually there are three main methods. The first one is benchmarks. Benchmarks refers to any technical evaluation, and I intentionally exclude any human evaluation from this. So benchmarks could be calculated automatically. For example, you could use LLM as a judge or as an oracle. I will tell you a little bit later about this technique. The second is use online metrics and online signal. This usually involves A/B testing, and actually everything is usual as you develop two different versions of Copilot, then you roll out it on two different groups of people and calculate metrics on how what's the behavior of these models. And the last one is offline signal. And this is what I will refer as a human evaluation. So any tasks that solved with human as an expert, I will refer to offline signals. And let's dive into each of these steps. So first is the benchmarks. As I told, it could be any technical automated calculated tasks. It could be any regular expression or any if-else statements, but the most interesting and actually valuable part for us is use another large language models as an oracle. So oracle is a frontier model that allows us to determine different properties of the responses that Copilot is generating. Let me give you an example. For example, tone of voice benchmark. So tone of voice checks whether the model maintains the tone of the dialogue. And to achieve this, we use a system prompt. So telling the model what is tone preservation or tone violation, and ask the model to assess the response. Here I would like to give a small life hack how to do it in a better way. And this life hack calls structured answer. So structured answer is a tool from OpenAI that allows you not to get just text response from model, but allows you to fill the fields of the structure you provided to the model. So for example, speaking about tone of voice assessment, we ask the model to evaluate mood, evaluate empathy, evaluate tone of voice, and only after this provide with a final score. And this is quite convenient for two reasons. The first reason is that you don't need to waste time for parsing, and we know that even high models sometimes struggle to follow the desired answer format. That's the first thing. And the second is that asking for mood, then asking for empathy, allows model to work like in step-by-step scenario and make better reasoning and chain of thoughts. So it also improves the quality of our benchmarks. Talking about pros and cons of benchmarks, the key advantage is that it's easy and fast to calculate. So it allows us to maintain lots of measurements and compare between them. And also this allows us to address specific issues. For example, we have benchmarks to assess empathy, proactivity, relevancy of the response, ethics, lack of harm, truthfulness, and also many other. So That's a good point of benchmarks, but talking about disadvantages, address specific issues. Actually, it's not a user signal, so it's not a live signal, so we priorly doesn't know exactly what's more important. So we cannot answer, does empathy more important than proactivity, or does proactivity more important than relevancy? And if we understand that something is important, it's sometimes not clear how to measure it. And also, as long as you use large language models to evaluate this, we face that Oracle could bring some noises to make answers inconsistent. And also, the benchmark qualities are limited by the Oracle's quality. So, quick summary is that benchmarks is a powerful tool, but you have to be aware about this cons and use it properly. The next is online metrics. I told you that it usually refers to A/B tests, but considering our Copilot, so as long as we provide users with 2 suggestions, it allows us to use actually side-by-side comparison. Side-by-side comparison is where the one suggestion is provided by one version of Copilot, and the second suggestion provided with another version of Copilot. And this allows us to measure the quality of each one and decide which one is better in terms of users' behavior. Online metrics obviously is the closest to the production business signal, so we can compute product metrics, and actually we can design A/B tests in the following way to compare different segments. And by segments, I mean different products, different users group, and actually different parts of the dialogue. And the only thing you need to do it's actually to have an A/B test platform. And I guess if you are not an early stage startup, you already have that one. But there's also no silver bullet, so there are some cons. The first is a gaming online metrics. So for example, imagine that we put some clickbait message in the Copilot as a suggestion, and what we could see? We could see that in short term it might lead to higher metrics, for example, higher click rate, but in a long term it could harm our business and user experience. So it's bad behavior. The second thing is the distribution of random dialogue doesn't represent model's quality. What it means? It means actually that lots of dialogues consist of things like, hi, how are you? And it doesn't cover all the model's capability. The next thing is also about A/B tests, that it needs weeks to get the result. And actually, weeks needed to get a statistically significant results, but actually if at early stage you see that your experiment is not as good as you expected, it's normal to stop it earlier. And obviously you need to deploy this model to the production, which affects the production. And this effects includes not only introducing new bugs, but also you could deployment with models that are weaker than already existed, it also harm business metrics. The last one, as I told, is offline signal, and I will refer, as I told, as a human evaluation. And let me rewind. So, early version of LLMs was early versions of LLMs wasn't a standalone product. So now when we use a Copilot, it's like a standalone product. So we understand the use cases and usage of this and could evaluate this exactly. And there are also 2 approaches of how we could do human evaluation. The first is a single metric approach. Talking about dialogue evaluation, we just could ask people the question, so how useful is the response for the communication? And provide user with the 3 options of answering. This is useless, this is somewhat useful, and pretty useful. Actually, it might be even more options. It actually doesn't matter. But if we want to get a more precise signal, it's better to use also side-by-side comparison. Because when we ask, for example, two different people about is this message useful, they could respond with different answers, while comparing two answers given a fixed dialogue, it's an easier task, and it leads you to more coherent responses of assessment. And also a good practice is to compare using side-by-side comparison against anchored models like Sonnet or ChatGPT. It's a good choice. Yeah. Now, digging about comparing online and offline signals. Offline signals have clear problems. The first is you need to hire assessors. The second is you need a markup infrastructure, so you need to maintain it, so you need to support it. Also, you need to develop instructions to users and actually train your assessors to follow these instructions. So it's a big task. And having an A/B test platform makes it tempting to use just an A/B tests, but the problem is, as I told, the distribution of the dialogues at A/B test are not covering all cases and capabilities of the model. As I told, you usually see just cases of how are you, but not the complex dialogues. And to clarify it a little bit, so let's imagine that we are coaching a volleyball team. So online metrics, it's like an evaluating performance of the team at the tournament game. And the match score gives you an overall information about how good your team is performing, but it doesn't give you information about where improvements could be. So to get this information, you need somehow to break down like part of the games and players separately. And actually, it's easy to do at the offline. In this example, at the training stage, is where you can simulate any situation and evaluate the performance of the situation. And actually, if we want to do this online, it actually makes you trying to spot the situation in the tournament game, or just wait when the situation occur. But many situations may occur rarely. So this is considered also the models evaluation. So the quick answer is that offline validation make you available to evaluate model capabilities in different situations and segments. So for example, different dialogue parts. And to put it all together, our final scheme looks this way. So first, we benchmark our models. This is like a preliminary selection of the models. This stage allows us to eliminate models with bugs, also some outlier models, and guarantees that to the further stage, only good models are provided. Then we use offline signal. This allows us to understand in a better way what's models' strengths and weaknesses, and actually, among the candidate models to choose the best one to move it forward. And the last one is online metrics, when we trying to understand the real-world performance and confirm that our expectation about models' behavior are expected as a production, and also that it drives business further. That drives business growth. And going back to that step-by-step picture, actually the reality is much more complex, and sometimes it's not possible to evaluate every version of the model. This is because the team of data scientists could produce, I guess, dozens of hypotheses. And hypothesis is any arrow, small arrow in that slide within few hours. So this may lead to a bad situation when some models have a negative effect. This is the red arrows in the slide. So that's why it's important to try at least to somehow evaluate each micro step. But if it's not, if some decision didn't evaluate it, you have to revise it later and validate to get rid of these red arrows. Yeah, actually, that's all. I would like to say that for now we are hiring, our team expands, and this is QR code that leads you and allows you to join SD Gang. So thank you, and I will be glad to answer your questions.
Thank you very much. Do we have a question in the audience for Dani after this interesting presentation? Yes, we have it over there in the last row. Thank you.
Yeah. Hello, thank you for the presentation. You said on the end you're choosing what's the best or not good model. How do you optimize this? Because overall you're going to match the people and you want people to stay on the application and continue paying subscriptions. But if you optimize better matching of the people, they will leave the application. So how do you watch this? How do you know which model is good or not?
So I guess this is about this slide. So we have lots of hypotheses of what could make user experience better. So we start making lots of these hypotheses, then filter some bad hypotheses with benchmarks. So this is allowed to, as I told, eliminate some outlier models, some bugs, and stuff like this. Then in the bunch of a smaller group of models, we starting to use an offline signal, so we understand the strengths and the weaknesses of each one, comparing between them, and then we choose the one model that we would like to evaluate its production. So this is the third step with online metrics. And online signal gets us information about does users like it or not. And also, as I told you, we usually use not an A/B tests, because A/B tests, it's two different groups of people. We use side-by-side comparisons. So we remain one suggestion with the existing production model and change the generation of the second was with the new one. And then analyzing which model is more like click-rated, and then decided is it good or bad. And this is in incremental steps. So in the time, the quality and the click rate also increases. Did I answer it? Yeah, if it's not, yeah, we could discuss behind the scene. Thank you.
Thank you. Any other questions for Dani this morning? I guess we'll leave it maybe for the coffee break and later. Thank you very much for joining us today. This is for you from the organizers. Thank you. Thank you once again. Thank you very much.